When MySQL executes a query, it follows a series of steps to retrieve and deliver the results as efficiently as possible. Understanding these steps can help in optimizing query performance. 1. Parsing and optimization. MySQL first parses the SQL query to check for syntax errors and validate the structure. After parsing, MySQL uses its optimizer to determine the most efficient way to execute the query. The optimizer evaluates different query execution paths and chooses the one with the least cost in terms of time and resources. 2. Query execution plan. The optimizer creates a query execution plan that outlines how the query will be processed, including which indexes to use, the join order, and whether to use sorting or temporary tables. This plan is designed to minimize the number of rows MySQL has to scan and to reduce disk I/O. 3. Depending on the query and available indexes, MySQL may choose to scan the table using index lookup. If there is a relevant index, MySQL can use it to locate rows faster. Range scan. MySQL scans part of the table based on a range of values. Full table scan. MySQL scans all rows in the table, which is less efficient and usually occurs when no suitable index is available. Number 4. Join processing. For queries involving multiple tables, MySQL needs to determine how to process joins. It chooses the most efficient join order, often starting with the table that has the most restrictive conditions, such as filtering rows by an index. MySQL typically uses nested loop joins, where it loops through one table and for each row, looks up matching rows in the second table. 5. Filtering and sorting. Once rows are retrieved, MySQL applies any where clause filters to narrow down the result set. Filtering is more efficient when the filtering columns are indexed. If the query includes an order by clause, MySQL sorts the rows. Sorting can be performed faster if the data is already indexed in the desired order. Otherwise, MySQL may perform an external sort using a temporary table. 6. Grouping and aggregation. If the query involves group by or aggregate functions like sum, count, AVG, MySQL groups the rows and performs the aggregation. Indexes can improve the performance of grouping operations. In cases where indexes do not cover the grouping, MySQL may need to create temporary tables to store intermediate results during the grouping and aggregation process. 7. Temporary tables. MySQL may use temporary tables for intermediate steps, particularly when handling complex operations like sorting large datasets, grouping, or handling union queries. Temporary tables hold data during these operations and are discarded after the query completes. 8. Returning results. After all the processing, scanning, filtering, sorting, etc., MySQL returns the final result set to the client. If the query uses limit, MySQL will stop once it has retrieved the specified number of rows, further improving efficiency by avoiding unnecessary data processing. Conclusion. MySQL processes a query by first parsing and optimizing it, then scanning rows, applying filters, performing joins, and handling sorting and grouping operations as needed. By creating a query execution plan, MySQL ensures the most efficient path to retrieve the required data.